Hello and welcome to Exploring Creation with Chemistry 2nd edition. Today we're going to cover the first half of Module 1. We're going to go all the way to example 1.4. This module can be found on pages 1 through 31 in your textbook, and mostly it covers math, units of measurement, the metric system, manipulating units, converting between unit systems, derived units, making measurements, accuracy versus precision, and then significant figures, how they are related, scientific notation, and density. We're not going to cover all of it today, but this is what Module 1 covers. Please make sure to have a photocopy of the periodic table ready in a couple of weeks. A tiny bit more than a couple of weeks because we're going to go over the periodic table in Module 3, and then you're going to start using it. So you can find a periodic table in your textbook cover. The front cover of your textbook has a periodic table, and you can also find it on page 75. I will provide you a PDF as well. It would be good if your photocopy was a color photocopy, so later we can talk about differences between the different elements, sections in the periodic table. But I need you to have this handy as a separate page so you don't have to flip back and forth to open your textbook to page 75 or open to the cover. This is just a hassle to have to go back and forth. Have a separate page with a copy of the periodic table. Now, what is chemistry? You're here to learn chemistry. What is chemistry? Page 1. Well, chemistry is the study of matter. So what is matter? What are we studying this year? We study anything that has mass and takes up space. You need to know the definition of matter. Anything that has mass and takes up space. You are matter. You have mass. You occupy space. Where you are, nothing else can be there. You take up space. How about the air around you? Do you think air has mass? Do you think it occupies space? Does it qualify as matter? Think for a minute about it. Okay, look at this balloon right here. This balloon is probably filled with helium because it's hovering here. And helium is less dense than air, so it goes up. Do you think the helium in this balloon qualifies as matter? Does it have mass? Does it have volume? Well, it's pretty easy to see that it does occupy space. It does have volume. It's inside the balloon. The balloon is containing it inside, but the balloon takes up space. Now, what about mass? Because both of them are requirements for matter. The helium rises, but if you take out the air around it, and you could put it on a scale, you would see that it does have mass. Helium is matter. All gases are matter. So I know that solids and liquids are really easy to visualize as occupying space and having some kind of mass, but gases are also part of what chemistry studies, all three. What about things in this world that do not have mass or take up space? Can you think of anything around you that you are familiar with that is not matter? Think for a second before you move on. Okay. How about lighting? What do you think about lighting? Does it have mass? Does it occupy space? Well, lighting isn't matter. It does not have mass. It does not take up space. So it does not qualify as matter. It doesn't mean that scientists do not study light. But chemists don't usually study light. We're going to have to cover a tiny bit of light to understand other things that chemists study in a later module. But if you want to learn more about light, you're going to have to study physics. Physics is a science that will cover light in great detail. Now, during the week, after you're done watching the video and you start reading your textbook and doing on your own, you are going to encounter experiments that you're going to have to perform this week and then send the lab reports to me for grading and for feedback. So there are different ways you can do that. You can do the experiments as you encounter them when you read, or you can wait until you're done with the first half of the module and do all the labs together. It's up to you. This is your course. Make it work for you. Experiment 1.1 can be found on page 2. And in this experiment, you're going to prove that air has mass. Now, in experiment 1.2, you're going to prove that air takes up space. Each one of the experiments in your book, in your textbook, is followed by a few paragraphs in which the author of the book explains what happened in the lab. So it's very important for you to read those sections. Make sure that you understand what he explains to you. If you don't, ask me to go over it with you during our virtual live face-to-face meeting that we're going to have at the end of the week. You can also email me to ask about it before you write your lab report. Okay, page 3. Moving on. Units of measurement. Why do you think it's important to report units? Well, in science, if you do not report units, your answer is not correct. I'll be giving you some grace, and I'll remind you if you forget to include your units. I'll remind you to include your units. Professors are not going to do that. They're just going to count it wrong. So it's very important for you to start paying attention and reporting those units. A number that does not have a unit attached to it is meaningless in science. What are we talking about? Monkeys, bananas, liters, centimeters? You need to tell me what you are talking about. Now, what is the name of the system of standard units that you use here in the United States? Is that the system that the world uses? Is that the system that scientists use? Think about it for a second, and then I'll give you the answer. Well, there are two systems that you use here in the United States. The English system, also known as a customary system, and the metric system of units. And you mostly use the English system in elementary school, and then maybe middle school you start working with metrics, metric computations. But it's something that you have to learn in school. I grew up in Europe, so I grew up just using the metric system. And when I came here, I had to learn how to use the English system. So there you go. You need to know both. But in science, they use the metric system. So you're going to have to become very familiar with the metric system and become very comfortable using units in the metric system. Why are we using the metric system? Well, scientists have agreed to use the metric system. That's one of the reasons. If everybody else in the world is using the metric system, then all scientists are speaking the same language. And when they look at data, they can read the data and understand it. Now, why did they decide to use the metric system instead of the English system? The metric system is really, really easy to use because you are using powers of 10 to do your math. So the computations are really easy. You multiply by groups of 10 or you divide by groups of 10. And in a minute, we're going to see how this works. Another reason is that the metric system has a ton of units, and you only have to change the prefix of a unit to have a new unit. And I'll go over that in a minute with you. You will need to be able to tell if a unit is in the metric system or in the English system. So if somebody gives you a unit like Newton, you need to know that it's for weight and that is in the metric system. if I say to you gallon, then you need to know that that is a unit in the English system for volume. You need to be able to do that on your own. That's going to be part of quizzes and part of tests, maybe review questions, and so on. So please make sure that you are familiar with some of the most common units. Different physical properties, length, mass, volume, time, temperature, and weight that scientists calculate come in different units for the different systems. You probably have worked with some of them. The meter, the gram, the liter, the second. Second is shared between the two of them. The Celsius versus the Fahrenheit. You will learn how to go from one system to another in a few more slides time. So don't worry about it too much. But just be able to differentiate between, is it metric, is it English? Now, mass is not the same as weight in science at all, okay? Mass in the metric system is measured with grams and kilograms and so on. In the English system, you have the slug, which I had never heard about the slug until I started doing Apologia chemistry. And you may not use the slug at home when you're measuring things, okay? And that is fine. But weight, you have the Newton in the metric system as its unit, and you have the pound in the English system. And you're gonna work with weight if you do physics. You're not gonna use a lot of weight in chemistry. When we talk, everyday talk, when you go and jump on a scale to measure your mass, you're actually measuring your weight, those pounds, how many pounds you are, 125 pounds. You are measuring weight. So you need to know that they are not the same thing. You need to know the definition of each. So mass is how much matter is there, how much of you is there. It does not change. It does not change no matter where you are in the universe. Weight, on the other hand, changes depending on where you are in the universe, because it takes into account your mass, but it takes into account gravity pulling down on the object that's being measured. So for example, your mass might be, I don't know, about 50 kilograms, something like that. It's the same here on Earth as it would be on the moon. Your mass, how much of you is there, does not change. Your weight, on the other hand, it's bigger here on Earth than it is on the moon, because gravity here on Earth is larger than the gravity on the moon. That's why you can see people, not people, but astronauts jumping and going really high up in the air and kind of looking like they're floating or flying on the moon. We cannot do that here because gravity on the moon is smaller. If you decide to take physics, you're going to learn all about weights and how it works and how scales work. Scales have springs inside of them, so they're actually measuring how gravity and the mass that's on top of the scale play together on pushing those springs down. But you're going to cover that in physics if you decide to take physics next year. Now, not only do you need to know if a unit belongs to the metric system or if it belongs in the English customary system, but you also need to know the difference between what a base unit is versus what an alternative unit is. Okay? So here you go. Quantities that are measured by scientists: time, length, mass, temperature, force, pressure, energy, and power. Some of them are just measured in physics, but that's okay. Quantities that are measurable. And then you have a unit, what's called the base unit. Alternative units are other units that you can use when you're reporting data. They are not the base unit, but they also measure the same quantity. For example, time, the base unit is the second, but you could use hours, you could use minutes to report time. Those are alternative units of time. Look at length. Length, the unit the base unit for length is the meter in the metric system. Alternative units in the metric system would be the centimeter, the kilometer. Here they give you an alternative unit in inches, which is in the English system. Both the English system and the metric system have base units and have alternative units. And just note that alternative units are other units. You need to be able to give me alternative units if I give you the base unit, or if I say to you, okay, can you differentiate between alternative and base units? If I give you the meter, will you be able to tell me that that is a base unit? If I say to you the pound, will you be able to tell me that is an alternative unit for mass? And so on. You know, that kind of thing. You need to be able to know, is this a English unit or a metric unit? Is it a base unit or is it an alternative unit? And you have tables in your textbook that have that information. So study them. And you also have Quizlet to help you study these. So utilize everything that I have given to you. Now, we already went over the advantages of the metric system. If somebody asks you why we're using the metric system instead of the English system, please know the reasons why we use the metric system. Everybody does it in the science community. They have agreed on it. So when you compare or share information, everybody's on the same page. It's easy to use because you are using a base of 10 to multiply or divide by 10, and that's easy math. And it has a ton of units in it. Lots of prefixes. A prefix is just a little bit of a word that you attach to the name of a base unit. So we have giga, mega, kilo, hecto, deca, deci, centi, milli, micro, and nano. And here's your base unit. You see value 1. So imagine that your base unit is the gram for mass. So you would attach gigagram, megagram, kilogram, hectogram, decagram, decigram, centigram, milligram, microgram, and nanogram. So prefixes are added to the name of your base unit, and you have created a new unit. There's lots and lots of prefixes in the metric system. You do not need to memorize them all. The ones I want you to memorize are here boxed in pink. So you need to know what kilo is, you need to know what centi is, and what milli is. And I'll go over these with a little step ladder, not this one, another one. For this slide, I just want you to notice that kilo is at the top of the ladder and milli is at the bottom of the ladder. These kind of ladders, okay, always show the bigger units at the top and the smaller units at the bottom. Okay, here. How does it work? Okay, this is what I need you to know. I need you to be really, really good at manipulating between these units. Imagine that your base unit is the gram and you have 1 gram. And you want to know how many kilograms you have in 1 gram. So you're going up to know how many kilos you have. What does it say here? It says for every step you take up, you need to divide by 10. That means you're going to be dividing by a total of 1,000. So if you want to know how many kilograms are in 1 gram, you would divide 1 by 1,000. You have 0.001 kilograms in 1 gram. You also can go the other way around. You may want to ask yourself, how many grams are in 1 kilogram? Well, you're going from kilo to gram. You're going down the ladder to a smaller unit. So what does it say? 1, 2, 3 bumps worth 10 each. You multiply by 1,000. So you have 1,000 grams in 1 kilogram. Follow the bumps. Do what the bumps tell you to do. You need to know about the kilo. It doesn't matter if you go up or down the ladder. The relationship between the two is the same. Okay? Now, You need to know about centi and millis. That C is used sometimes. So if you want to memorize it, that's good for you too. But centi and milli we're going to be using a lot. So imagine that you want to know how many milligrams are in 1 gram. You're going down to find out the milligrams. It says to multiply by 1,000. So this 1,000, milli means 1,000 grams, milligrams in a gram, milligrams in a gram, 1,000 of them. You can go backwards up and say, how many grams do I have in 1 milligram? It says to divide by 1,000. So we have 0.001 grams in 1 milligram. Please make sure that you understand the latter and start memorizing the relationships between the different prefixes because you're going to be using it a lot. Okay? A lot. I hope you're taking notes. I hope that you are actually taking notes on this material. It's not enough for you to watch the video. You need to involve yourself in the learning. Take notes. You can pause this. This is a video, so make it work for you. I also recommend that you work through the examples with me when I go over the examples, not only the extra practice problems that I require you to do, but actually try to take notes when we are covering the examples. Active learning. Now, we're going to be using the factor level method a lot this year. And if you go into physics, you're going to use it some more. But the factor level method is just a very fancy name for a very simple concept. The factor level method allows us to go from one unit to another. Okay? So for example, how many minutes are in 2.5 hours? So you want to know how many minutes? You had hours. Going from hours to minutes is what I mean when I say I want to go from one unit to another. Anytime you have problems like this, you have to convert units, you're going to use the factor level method of conversion. It's very simple. You start with the number they give you, so 2.5 hours. You open a fraction line, and then you're going to put the units you're trying to change. You're trying to get rid of the hours at the bottom of your fraction. The new units always go at the top of your fraction, because if you put it like this, top and bottom, now this cancels. This is algebra. Hours cancel hours, top, bottom cancel one another, because it becomes 1, and 1 does not change anything. Multiplying and dividing by 1 does not change anything. Sometimes when I do math problems, I do not put the multiplication sign between this number and my fraction because it's implied. Lots of professors, a lot of math teachers do not put a multiplication sign. So just know that if you don't see multiplication sign, it's still multiplying. Tops multiply, whatever is in the bottom multiplies each other, but top and bottom divide. A fraction is a division. So do the math, put it in the calculator, 2.5 times 60, and then you have your answer, 150 minutes. Hours got canceled, you were left with minutes. To be able to do that, I need what's called the conversion factor. The conversion factor is the mathematical relationship between the two units that you are trying to connect. So I knew that in 1 hour there were 60 minutes. Notice that the 60 goes with the minutes. So the number 60 needs to be next to the unit minutes. Conversion factors. We're going to talk about it in a tiny bit more detail in a minute. First, we're going to do this example. Example 1.1 on page 9. It says a student measures the mass of a rock to be 14,351 grams. What is the rock's mass in kilograms? I put the prefix table right there for you, just in case you have not yet had a chance to memorize this. But you need to start thinking about memorizing this information. The ones I said, the kilo, the milli, and the centi. And if you want, the deci, because you're going to use that sum as well. So let me go to the whiteboard and let's get started. Okay, remember what I said to you. I said to you that the first thing you need to do is to write down the number they give you. So in this problem, let me get it white. They give you 14,351 grams. And they want to know the mass in kilograms. I said to you, open the factor level method fraction line, and then put the units that you're trying to get rid of at the bottom. So grams can cancel one another. You see that? That's why we put them top, bottom. And then put the new unit at the top. Next. Okay. This is kg, but just in case, okay? Kg for kilograms. So this is how you do it. You put grams at the bottom so it can cancel. New unit at the top. I'm gonna erase this. I wanted to spell it, but kg, better to get used to the different symbols for different things. So kilogram. Now you need to write, I'm gonna put it in blue, the conversion factor that relates one another. How are they related? How are kilograms and grams related? Well, I know that I have 1,000 grams in 1 kilogram. This is a conversion factor. This is how they are related. I could also have done this. I could have done it this way. Grams at the bottom and my kilograms at the top, and I could have said that in 1 gram, I have 0.001 kilograms. This is also true, okay? It doesn't matter which one you put in there. It doesn't matter. The answer is going to be exactly the same. I like this one. My mind thinks this way. But if your mind thinks this other way, that is fine. The relationship needs to be true for it to work. So make sure that the relationship is true. That is 0.01 kilograms is 1 gram. The numbers need to be in the right position. So use the factor, the factor level methods to solve these kind of problems, but also use the conversion factor that works for you. Let me erase this. My pen, go back to my pen. So if you do the math, remember what we said. These are multiplying, okay? Those tops are multiplying. One is not going to change anything. And then divided by 1,000. Remember that this is also like a fraction. You always can put a 1 dividing or multiplying. It doesn't change anything. So this top divided by the bottom. Always. And if you do the math, you'll find that you have 14.351 kilograms. That is your answer. You just converted your grams into kilograms. It's your turn, okay? Let me erase this and show you what I want you to do. I want you to do extra practice problems 2 and 3. You can find those extra practice problems on page 569 in your textbook. I would recommend for you to put a little tab that you can move forward as we move along with the different modules. That shows you where you have your extra practice problems, so you don't have to find the page every single time. You're going to be working on all extra practice problems this year, so you need easy access to them. I'll give you the answer to the problem first. If you got the answer right, move on. This is a video, you can skip forward until we have more instruction. If you didn't get it right, you can try again if you want to, or you can watch me solve it for you, okay? So you have options. Let me get started. So number 2, the answer for number 2, let me find it. The answer for number 2 is 1.31 times 10 to the 3 centigrams. This is in scientific notation. Start getting used to it. I'm going to review scientific notation. You should have covered this in your math courses, but if you haven't, I'll be going over it. Now, how did we solve this? So remember, if you got this number, move on. If not, watch me to see how this is solved. I said to you, always start with the number they give you. So 13.1 grams is what they give you. Open your fraction for the factor level method. Write down the unit you're trying to get rid of at the bottom. the new unit at the top. This one now disappears. And now find the numerical connection between the two units. What is the conversion factor that unites them? Well, what do I know? I know that the word centi means 100. So I can put 100 centigrams in 1 gram. And remember, you could have done it the other way around. In 1 centigram, 0.01 grams. So it has to be true, but you can think going up or going down. How do you want to do it? How do you want to solve it? Just make sure that the equality is the correct equality. Now, when you solve this, 13.1 multiplying the 100, okay, divided by 1 doesn't change anything, you're going to get this number, okay? So that's how you solve it. Now, for number 3, the answer for number 3, because that's the next extra practice problem you needed to solve. So number 3, your answer should be 0.0451 liters. If this is the answer that you got, you're done, move on. If not, then watch to see how this is solved. I'm gonna try to make that L a tiny bit prettier. There you go. So how is this solved? Always start with what they give you, 45.1 milliliters. Open your fraction. Remember, there's a multiplication. If I don't add it here, it's implied. Put the units you're trying to get rid of at the bottom, the new unit at the top. Now think, how are they related? Milliliters and liters. Milli means 1,000. So I know there's 1,000 of them in 1 liter. Okay? So if you do the math, you'll find that your answer is that 0.0451 liters. And the only thing you're doing is multiplying the tops, dividing by 1,000. Okay, ask questions if you don't understand how we solve this. You can watch the video again. Okay, you can rewind and go step by step and watch it again. This is a video, make it work for you. So erase. Now, let's move on with our instruction. So converting between unit systems. For this module, you need to be able to convert from the English system to the metric system. In the future, when we do math, we're going to be using the metric system. But for this module, you need to be able to go from the English to the metric, not just within the metric from one prefix to another, but also from the English to the metric. To be able to do that, you still need your conversion factors. How are they related, those two things that you're trying to put together? For example, distance. I would recommend for you to memorize this one. You're going to be using it a lot. 1 inch is 2.54 centimeters. That's how they are related. You need this to be able to go from inches to centimeters or from centimeters to inches. You need this information. Slug, 1 slug, 14.59 kilograms. 1 gallon, 3.78 liters. And sometimes they'll give you these. The problem will give you these. But sometimes it won't, and some of them you need to memorize. For example, this one, okay? So you do exactly the same thing you did when you were trying to move from one prefix to another. You're going to be using the factor level method. You're going to start with a number they give you. For example, you have 4 inches, but you're trying to find how many centimeters you have in 4 inches. Well, you open your fraction. You put the inches at the bottom, the new unit that you're trying to find at the top, they disappear, cross over. And this is the relationship. This is the numerical relationship between the two. In 1 inch, 1 goes with the inch because that's what it says here, 1 inch, 2.54 centimeters. That goes with the centimeters. It needs to be with the centimeters as well in your fraction. And if you do the math, tops multiply, divided by 1, nothing changes, you get 10.16 centimeters. Now, let's do example 1.2 to see how this is done. Okay, let's put it all together. So it says the length of a tabletop is measured to be 37.8 inches. How many centimeters is that? Always read your problems, find out what they're giving you, what they're asking. they're going to get a lot longer than these. So train yourself to read those problems. Okay, so what did they give us? What did they give us was this number, 37.8 inches. That's what they gave us. And they want that information in centimeters. So we need to open our line for the factor level method that we use to solve this kind of conversions and think, okay, my inches need to go at the bottom so I can, cancel one another, top, bottom, cancel, becomes 1. And I want my new units at the top, so my centimeters at the top. Then I think, how are they related? Well, according to the table, 1 inch is 2.54 centimeters. Okay. Now remember, these are multiplying, the tops are multiplying. Get used also to using parentheses. Parentheses are helpful if you have other numbers at the bottom. This is a 1, so this 2 would be multiplying as well. But top divided by whatever you have at the bottom. And parentheses help with that because you can put parentheses everywhere. Just remember to close your parentheses. So if you were using parentheses, imagine you have bigger numbers than these. You would open a parenthesis, put 37.8 times 2.54, close your parentheses, the division symbol, and then open parentheses and put any numbers that you have at the bottom, close, and then your calculator would calculate this for you. Your scientific calculator. Please make friends with it. It's going to be your best friend this year in chemistry. So when you put all these numbers in, multiplying divided by 1 is not going to change anything. Your value is 96.0112 centimeters. Okay? There you go. That's your answer. Now it's your turn to prove to me that you know how to do that. Not yet. In a minute. Okay. More complex unit conversions. And you may have done this in math. I know that some math curriculums have already covered this by the time you take chemistry, and some may not have. It's not too complicated. It just means you have more steps to go, multiple steps to go. Instead of just one easy conversion, you have to keep converting things. That's all it is. For example, you're going to have problems that look like these. Convert 4,523 centiliters to kiloliters. So you know that you are going from the centiliter to the kiloliter. And as you can see, there are 3 bumps, okay? And you're going to need to stop by what is called the base unit. The liter is the base unit. You have memorized the relationship between centi, anything that's centi, and the base unit, 100 of them in one. And you also have to memorize the relationship between the base unit and the word kilo. There's 1,000 of these in 1 kilo. And because you already have memorized these, you're going to do the steps to move from one to another. And what do I mean by that? You ready? Let's look at the example and you see how this is not that complicated, it's just a tiny bit longer. The mass of an object is measured to be 0.030 kilograms. So what is the object's mass in milligrams? So you go from your kilo to your milli, top to the bottom. Wow, there's a lot of bumps separating them. And if you had this in front of you, you could multiply by 10, 10, 10, 10, 10, and convert it directly. But I said to you, you need to know how many bumps you have between one prefix and another to be able to do it this way. But if you stop by the base unit and you already have memorized the relationship between kilo and the base unit and milli, you don't need to know how many bumps there are between one unit and the other. Let's see how this is solved. Ready? Okay, let me copy this. So we're starting, let me get this one in white, 0.030 kilograms. As I said, go to the base unit first. The base unit is going to go here. And then from the base unit, you can go to the next unit. So it's a multiple step problem. The kilogram needs to go at the bottom because you want to try to cancel that. You want to cancel it, so it needs to be at the bottom to cancel it. And your base unit for mass is the gram. And then from the base unit, you need to go to the unit they want you to solve this for, so the milligram. Then this is also going to be canceled, and you're going to be left with a milligram. This is what I mean when I say go to the base unit first, because you are supposed to memorize how kilo and the gram unit are related, and also how milli and the base unit are related. But you don't need to know the direct conversion between those two. Stop by the base unit, and then things get a tiny bit easier. So now that you have the units in the right position, start thinking, how are they related? Well, I know that I have 1,000 grams in 1 kilogram. So far, so good. I also know I have 1,000 milligrams in 1 gram. Now I have everything I need. The tops multiply, so multiply all these numbers together, multiply them all, use your parentheses. The 1 is not going to change anything. Sometimes you have other numbers at the bottom. Right now you only have a 1, so not going to change anything. But if you put it in your calculator, you'll see that in 0.030 kilograms, you have 30,000 milligrams. And this is your answer. This is the answer you should be getting. Okay. Now you do have some of this kind of problems to do on your own. I want you to do extra practice problem number 4, and you can find the problem on page 569. I'll give you the answer. Move on if you got it right, or watch me perform it if solve it. If you make a mistake, you can try it again on your own without watching to see how I'm doing it. But if you need help, watch the video. So here we go. The first thing you need to do is read the problem, okay? So number 4. Number 4 reads like this. If a road is 13.1 miles long, how many inches long is it? And they give you the conversion factor that will help you go from a foot to inches and then a mile to feet. They give you all the information you need. There's nothing they're missing. So how do you do this? How do you do this? You always start with the number they give you. So let me put that in white. 13.1 miles. Okay. I said to you, stop by the base unit. The base unit here is the feet. And if you didn't know that it was the feet, you could look at the information they give you and see that there's foot to inches and then miles to feet. So the unit that's being repeated there is the feet. The feet is being repeated in both conversion factors. So that should give you a clue that that was the middleman. That was your base unit. So the miles are going to go at the bottom. Your feet are going to be at the top. Then you're going to have another step to go, because the miles are going to be gone. Thank you. Goodbye. And then you're going to have to go from your feet into your inches. They wanted the answer in inches. See that? So the feet cancels one another as well. Now use the conversion factors the problem is giving you. So what does it say here in parentheses? It says that between miles and feet, it says that 1 mile is 5.280 times 10 to the 3, okay? Feet, that's given to you. They also are telling me that in 1 foot, there are 12 inches. You see? That's the information that was in parentheses in your problem. Now, everything that is at the top will multiply one another. So 13.1 multiplying 5.2 times 80 times 10 to the 3 times 12. Make sure that you know how to enter these in your calculator. You should have a key that looks very similar to x10, and then exponent, the word exponent, 3. If you are not familiar with your scientific calculator, you need to get familiar with it ASAP. Go to YouTube, Google the name of your calculator and say, how do I use it? And usually there are tons of videos out there that teach you how to use your calculator. You can also read your instruction manual, but I like videos better than the instruction manuals that come with the calculators. So when you do that, all these multiplying divided by 1, it's not going to change anything. When you do the math, the computation, okay, the computation, according to my numbers, you should be getting this number, 8.30 times 10 to the 5 inches. So there you go. Stop by the middleman, the base unit, because you know the 2 conversion factors on either side, and just keep going, keep opening your fractions to solve this kind of problems. Okay, let me erase all of this so it's ready for the next problem. I said to you to please make sure that you know how to use your scientific calculator. If you didn't watch the solving the problem section of the video, if you skip that because you know how to do that, please make sure that you know how to use your scientific calculator. Now, derived units. So we talked about metric system versus English or customary system. We talked about base units versus alternative units. And now we're talking about derived units. What on earth is a derived unit? Derived units come from doing math. Okay? For example, somebody is multiplying 1 meter by 1 meter. When you do that, 1 times 1 is 1. Meter times meter is meter square. This meter square is a derived unit. It derived from doing math. And of course, you're going to be doing a lot of math in chemistry and a lot of math too in physics if you take physics. So those units that come out of doing math are called derived units. These right here are derived quantities. They come with an equation that allows us to calculate them. Area, length square, volume, cubic length, density. This little thing right here is density. You're going to be using it in the second section of module 1. So mass divided by volume. Velocity, acceleration, and momentum are used in physics, but you can have some problems in this section where you have to practice your math that have to do with area, even though chemistry does not really require you usually to calculate area. But for this section of the module, you do need to know how to calculate area. So look at the derived units. When you put your units in the equation, this is the unit that you come out with. Meter times meter, meter square. Meter times meter times meter, cubic meter. Mass, kilograms, divided by what? Cubic meters. Okay? That's a derived unit. So know what it means to be derived when you are a unit. Now, cubic centimeters or milliliters, what is the difference between the two of them? Well, they are the same. There's no difference between a cubic centimeter and 1 milliliter. Nurses use cubic centimeters when they give you an injection. So if you have a doctor or a nurse giving you an injection and they're counting how many cubic centimeters are going to be going into the syringe here, they're talking about milliliters. So cubic centimeters, centimeters cubic, is the same as milliliter. Let's look at an example. Page 16, example 1.4, that's going to be our last example. It's going to demonstrate to you how derived units work. It says the length and height of a small box are measured, and they give it to you, length, height, and width, okay? So they want to know the volume in liters for this box. What is the volume? You need to know the, oops, sorry, I meant to go here. You need to know the equation that allows you to calculate volume. Hopefully you have done that in math, but here we go. Volume equals length times width times height. So you need to start with the right equation that allows you to calculate whatever they ask you to calculate. And then what do? Well, you put the information in. So we need to put the information in to find the volume first. 1.1 inches, they give us the information in inches, times 3.2 inches times 4.6 inches. Okay, put everything in the calculator. What do you get? Well, according to my notes, you should be getting 16.192 cubic inches. You had 1, 2, 3 cubic inches. The units also multiply, okay? They're multiplying. So is this the answer? No. The question here was, what is the volume in liters? They want to know how many liters. Well, do we have a straight path between cubic inches and liters? No, we don't. So the next step is for you to think this through. How do we go from one unit to another? How are all these units related? I want to end with liters. I'm starting with cubic inches. Well, I know that there's something called cubic centimeter, which is also spelled like this. Okay, those two things are the same. That do relate to milliliters, and I know that those relate to liters. Do I have an easy way to go from inches to centimeters? Well, you should remember that you had this conversion factor. 1 inch equals 2.54 centimeters. That's how they are related. And I said to you, please memorize these conversion factors. So if I follow this path, I will be able to go from my cubic inches into my liters, okay? I need to do 1, 2 steps in the middle. Okay, let's do that. Let's do that. Let me erase this and start with the number that I found for my volume. So my volume, when I calculated the volume, was 16.192 cubic inches. Okay. So remember what it means to be in a cubic inch. This means this. It means that you have inch times inch times inch. Each one of them needs to be changed into centimeters. So open 3 fractions. I'm going to put 1 inch here, 1 inch here, and 1 inch here. So I'm going to have my centimeters here, and centimeters here. Each one of them needs to be converted into centimeters. How are they related? We said that 1 inch is 2.54 centimeters, each one of them. Okay. My first inch is gone. My second inch is gone. My third inch is gone. And I'm going to be left with centimeter times centimeter times centimeter, which is my cubic centimeter I was trying to find. You could have just done this, 16.192 cubic inches. Open your factor level method and put 1. This is 1. Whatever number it is. In this case was 1, okay? Cubic inches is 2.54 cubic for the cubic centimeters, okay? If you are very familiar with conversions, you may want to go this way. You can do it this way, it's quicker. But you can break every problem step by step. Think, okay, what's a cubic inch? It's 3 of them. Each one is to be converted. So open your factor level method 3 times and change your units. Put everything in the calculator. The tops are multiplying. So 16.192 times 2.54 times 2.54 times 2.54. And if you do that, you'll find that you have 265.338, that's an 8, cubic centimeters. Are we done? No. They didn't want the answer in cubic centimeters. So let me erase this section here at the bottom so we have some space to keep converting units. Just keep on going. Just keep on going. Where are we going? Well, before I can go to liters, I need to convert those cubic centimeters into milliliters. What do I know? I know that 1 cubic centimeters, which is the same as 1 cubic centimeters, you can spell it both ways, is the same as 1 milliliter. This is my conversion factor that relates my cubic centimeters with my milliliters. So basically what I have is a 265.338 centimeters. Now I can call them milliliters. You see that? Because it's 1 to 1. You're not changing anything. Am I done? I'm sorry to tell you that I'm not done, because we still need to convert all of this into liters. So let's erase all this information. Leave that there because you're going to need that number. And I'm going to do a different color so we don't get confused. I'm going to go back to white. So what do? Well, you start with the number they give you. So 200, or that you found, 265.338 milliliters. I open my fraction for the factor level method. I put the units I'm trying to get rid of at the bottom, the new units that I want at the top. And then I think, how are they related? Well, I know that there is 1,000 milliliters in 1 liter. So 1,000 milliliters in a liter means that you're going to have to divide this number by 1,000. Those two are multiplying, but the one is not changing anything. Everything at the bottom divides the top. Okay? So the calculator should shoot out at you an answer like mine, 0.265 338 liters. And that is the answer they wanted. This is what they wanted because they wanted liters. So the math itself is not very complicated. It's just lots of steps. Just keep going, keep thinking. Write yourself a path to follow if you need to. I need to go from here to here, from here to there, and just keep doing it. Okay. Making measurements. How do we do measurements in science? Well, you need to use the right tool to do measurements. Okay? Know how to use the tool is very important as well. So for chemistry, you're going to be using thermometers, stopwatches, beakers, graduate cylinders, pipettes, stuff like that. Balances, not a triple beam balance. Most people buy an electric one, but know how to use your tool as well. And what do I mean by know how to use your tool? Well, use the right tool. Trying to measure something that is like the length of something, whatever. This is a ribbon, okay? Use a ruler. Know the scale. Know the units that you're using. You're used to using inches, but in science, you will not be using inches. You're going to be using the metric system. So Another thing you need to remember when you use a ruler, for example, you're going to be using rulers for some of the experiments that are coming. You need to start at 1 centimeter. This one is in inches, but at 1 centimeter. Why not at 0? Why don't we start measuring at 0? Think for a second why you think we don't start right here. Well, if you guess that your ruler may have some problems because it might be an old ruler and this is worn out, so it's not very precise. The beginning line right here might not be there. All kinds of problems like that. You want to be precise. You want to be accurate in your ruler. So you don't want to start at 0. You want to take that factor out of the equation when you're doing measurements. You don't want to make mistakes. Pick up a place where the number is very clear for you to read, and then take away the 1 in the front. Don't forget to take away the 1. Okay. This is what I want to talk to you about. Okay, the rulers you're going to be using for science are going to be in centimeters, okay? So make sure that your rulers have centimeters in them. Now, the second thing you need to notice is that the scale of this ruler and the scale of this ruler do not match. They are 2 different scales. So once you have picked up your tool, the ruler, to measure this ribbon that's blue, and you have noticed that your scale is, your units are in centimeters, then you need to read the scale. Read the scale. There are 10 little lines between 0 and 1, 1 and 2, and so on. These are your centimeters. Each one of them is a centimeter. And each one of those little lines is a millimeter. Okay? And there are 10 of them in 1 centimeter. Each one of them has 10. This one only has 5 little lines. What does it mean to have just 5 little lines? That means that each one of these lines is worth 2 milliliters. So 0.2, 0.4, 0.6, 0.8, 1. That's how you read it. Now, this measurement and this measurement are similar, but they are not exactly the same, are they? This one is stopping in the 10th position. This one is going all the way to the 100th position. The smaller the scale of your tool, the more digits you can give me after the decimal point. In a minute, you're going to see that that is precision. Okay? The more digits you can give me after decimal point, the more precise you can be with the tool you are using. Now, let's take a closer look. If you look at this ribbon right here, you know for sure that it's 4 centimeters, and then you keep on going and you start counting the little millimeters right here, and you reach the 9, okay? You can count up to 9, no problem. And then you see that the blue actually ends between the 9 and the next centimeter, 5. Someplace in there. We don't know exactly where because there's no little line here to help us. You had to guess this 5. 4.95 could have been 4.96, 4.97. You had to guess this last digit. Okay. The ruler could very well measure up to the 10th position. The 100th position was a guess. Look at this one right here. For this ruler, you can measure very, very well to the 1st position, 4 and 5. Then you have, each one of them has a value of 2, so you get to the 8. That 9 is a guess. You're saying it's 9. I'm going to look at it and say maybe it's 4.88. Everybody can see something a tiny bit different. So this last digit is a guess. The smaller the scale, the more precise you can be with your measuring. When you're measuring anything, you always need to give one more digit that the scale can read. So accurate up to the 10th, the hundreds is a guess, you need to give me the hundreds. You need to give me that one digit that is a guess. The scale can read up to the ones, so you need to give me one more. Give me the digit that's the guess. And you're going to have to do that for all your data measurements for your experiments. Give me one more. Always one more. Now, graduate cylinders, okay? You need to know how to read a graduate cylinder. You're going to be using them a lot. In chemistry, I mean, just period, you're going to be using them a lot. And this is a glass one. In a minute, you're going to see a plastic one. But when you read a graduate cylinder, I said to you, the first thing you do when you are using a tool is look at the units. Well, here we go, milliliters. Then look and see what kind of scale they have. Well, between the 10 and the 20, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 little lines. Means each one is 1 milliliter. Great. And then how do I read these? Well, this area where the liquid stops, if you see, is a curve. Sometimes it's tiny more curve than others. This one is kind of a flattened curve, but sometimes it's very, very obvious it's a curve, okay? This is called the meniscus, and it just happens when you have glass that's in a tubular format. So you have a tube, a cylinder, you have a cylinder. And when that happens, the water creates this illusion and it attaches to the side of the glass right here and it pulls it a tiny bit up. So know that this is called the meniscus. And when you have a meniscus, there is a right way of reading it and a wrong way of reading it. When you want to read the meniscus, you always read the bottom part of the meniscus, not the top part, okay, but the bottom part of the meniscus. Now, if I was reading this graduate cylinder, I would say, okay, I know for sure this 10 milliliters and then 1, 2 for sure. Remember what I said to you. It's not just 10.2 because the scale can read up to there, but I need to guess the next digit. Well, if I thought this was on top of the line, I would say 10.20. I would include that 0. If I thought it was a tiny bit below, I could say, well, maybe it's 10.19. See? Always give me one more digit that the scale can read for whatever tool you're using. Glass versus plastic. Plastic, straight line. Glass will give you meniscus. There's a right way of reading this and a wrong way of reading this. Go back here for a minute. Do not pick up the graduate cylinder and put it in front of you, maybe, looking up through a window so you can see more clearly the liquid. You cannot do that. The graduate cylinder needs to rest on a flat surface. The liquid needs to stop moving before you start reading the meniscus, okay? You are the one that's going to have to go down to read the meniscus. So your height is to go down, so your eye is at eye level with the meniscus. Do not pick up the graduate cylinder. That is wrong. And we are trying to train you to be a good scientist. So back to this picture, plastic, straight line, there's no meniscus, just read what it says. When you have the meniscus, everything on a flat surface when you're trying to read it, and read the bottom. Okay, I cannot emphasize how important this is. And always give me one more digit, one more place, and the scale can read. Okay, this is the end of the first half of Module 1. You're going to need to read your textbook for this section. You're going to add notes to your notes if you need to. You can review all your examples if you need to. There's one extra practice problem I didn't do. I want you to do it on your own and turn it in. I want you to work through all the on your owns as you encounter them, okay? Because I don't want you to make mistakes that become a habit. I want you to correct them as you go. you're going to find the answers to the on your own at the end of the module. So do 1.1, correct it, then move on to 1.2, correct it, and so on. You don't want to move along making the same mistake. Now, remember to study for your conceptual weekly quiz. That's going to be an online quiz. That's going to be self-grading, and they will let me know how well you did. So study for those weekly quizzes. I need to make sure, because you're at home, that you're actually doing your work. Now, do all the labs assigned for this section. Some modules have more labs than others. So if you have things that you need to do, and you know that you're going to be busy, manage your time in a smart way. Do your labs ahead of time if you want to. And remember that each lab is explained to you in the textbook, but if you do not understand the results or why things are the way they are, ask me questions before you turn in your lab report. You're not going to have a test after the first half of Module 1, but in the future, for future modules, usually the test is scheduled on the same week that you do the first half of a module. So if you had a test, you would have to take test assigned as well. Okay, I hope you enjoyed this first lesson, and have a great week.